The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Hey Ben, I was looking around in our cabinet the other day and I noticed we've got some Intel Edisons in there.
Oh yeah, Intel Edison is the cool, small, modular x86 based development system that you can easily embed in things. It also has an Arduino compatibility mode, so you have the power of Linux and Arduino.
Can you think of any projects in which we could put one?
Well, the Edison does have a built-in Wi-Fi and Bluetooth module, so perhaps we could make some sort of internet radio boombox.
Like a sweet 80s style boombox? So you can like put it up on your shoulder and be like, ooch, 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 ooch. And you can like walk around the boardwalk and be like, hey babes, check out my sweet boombox. It's connected to the internet. That sounds like a great project.
Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, here's the plan of attack for the Intel Edison radio boombox. First, we need to find an old boombox that looks like it came from the 80s and take it apart. Then we're going to see what parts inside of the boombox we can still use. Maybe the transformer, battery pack. We might as well keep it as original as possible. That'll also save us time. Whatever circuit we find inside, we will turn it into a line-in device so we can take the output from the Intel Edison's USB audio device and put it into the existing audio amplifier circuitry in the boombox. Then Felix, because he's the Linux master, is going to work on getting Edison with Linux to stream music off of the built-in Wi-Fi that the Edison has. Then we'll build the Edison unit into the boombox, and then finally add any additional new controls and sensors that we can to the unit. Let's get started. I ordered this sweet vintage boombox off of eBay. It's amazing how 20 years ago this kind of stuff was garbage, and now it actually costs decent money. So if you're looking into a CRT television for gaming, you should probably buy one now while they're garbage before they become rare. This thing takes 6D batteries. Not much takes D anymore, except for old boomboxes. Ah, look at all the simple Phillips screws. It was a better time when you could easily just open up your electronics. It smells older than it looks. I mean, it looks like the late 80s. It smells more like the 70s. Whoa, look at this big greasy knob. Look at that. Holy crap. Oh, it's got like bugs in it and hair. Oh, maybe it's not a bug. Maybe it's just like a black piece of crap. Oh, look, see? Take the front of the unit off quite easily. Oh, look, there's the microphones. See? Left and right microphones. We could record our own music on this. Oh my gosh. Oh, that must be the motor. Oh yeah, it's hooked up to the thing that says motor. Well, we've got a nice big transformer here. And the batteries, looks like the batteries go over into a disconnect. So the eBay ad for this just said vintage. Vintage is one of those terms that people use incorrectly, kind of like literally. Because you can't just say vintage, you have to say what the vintage is. Like, ooh, no one would say this is a vintage wine. You would say it's a 1978 vintage wine. Oh my gosh. I think this thing is from the 70s. So electronics from the late 70s to early 80s, when you desolder things, they have a certain smell. It actually smells a lot like Tang, which is also a popular thing from the early 80s. So yeah, this thing is actually older than I originally thought. Yeah, so this is probably going to be your amplifier here. This is probably going to be some sort of radio circuit. Most of your radio's over here. This is probably working on your tape deck controls, but I don't really see any circuits on this whatsoever. There's some, okay, that's not metal. That's probably just some sort of insulation. I don't know what we'll find on the other side. All right, well, let's keep digging into it. I'll keep the soldering iron handy just in case we have to remove anything else. The amount of Fleetwood Mac that was probably listened to on this radio is incalculable. Oh, that must just be acting as some sort of RF shielding. So you have 120 volts AC, it goes into the transformer. Transformer knocks it down to 10 volts AC, it's still AC, and that goes through the full wave rectifier, which turns it into DC, which goes into the boombox circuit. Yeah, I think we should just keep this power supply so we can use batteries or this, and then we can knock it down using better modern regulators to the actual power supplies that we need for our circuit. But we can use the full power of the 10 volts for the amplifier part. I'm probably gonna change some of these wires though because they look a little worse for wear. I was thinking that I'd kind of like to use the original audio amplifier because A, we have it, and B, then we can still use the volume, tone, and balance knobs. So if you look at the traces here, so this is volume, and it's a stereo, so that's why there's obviously two of them. And what it does is it basically pulls the two lines closer or further from ground. See how we have a ground plane going across all of these? And then the balance pulls one line or the other closer to ground. And the tone runs it through some capacitors, so it's probably acting as a high or low pass filter. So what I want to look for here are two traces, you know, because it's stereo. Let's get the multimeter. All right, so this is a one-sided board. We have some bridges here. So I'm guessing these are the audio coming from either the tape deck or the FM tuner. So we have this switch here, and this was switching between radio and tape. And look at all these different poles that it changes. It's just a big mechanical switch, and that's all that really you're doing when you switch it. Okay, so here's left and right. Let's follow the outermost one. It's getting a little more confusing. Okay, so it goes to that jumper there, which goes here, which goes here. I bet if I switch it, it goes to this one. Yep, so this is going to be from the tape, and this is from the radio. So this switch is basically saying which thing is outputting to the amplifier. So we could probably use these two as the input. So what we can do is we can basically lift up these bridges and patch in a cable. Let's try it. Hey, we could probably use this switch to power the system, or to turn it on and off. Because it's actually, you know, it's pretty much what's happening. Like, if you're in radio mode, it's on, and then if you're in tape mode, it turns off unless you push play on the tape. So switching the tape mode is like turning the whole thing off, as long as you don't have play pushed on the tape. We could probably attach this anywhere, but I'm just gonna attach the stereo wires here. All right, I need to figure out where the ground is, the ground reference for this. So I'm looking for big flooded planes. Well, this seems pretty obvious. I think that's safe. All right. Is it secret? Is it safe? I did notice this. There's a switch here that closes, and this probably involves the tape deck. So I'm wondering if that has to close in order for there to be power. So either the tape deck has to be in a certain state. Actually, I don't know. Well, I guess there's one way to find out. We can hook some power up and see what happens. All right, so the light comes on. Of course, we don't have any speakers hooked up. Let's see if we can jerry-rig this enough to test. Well, I think I should just plug my phone in and see what happens. All right, I found something a lot cheaper than my brand new cell phone. Of course, it's the original Castlevania on Game Boy, which is pretty slow, so it's more like oh, time to jump. I'm on the moon! All right, well that seemed to be pretty straightforward. Okay, now I'm gonna test it with the expensive thing. So this was the canary in the coal mine. Here's my plan. I'll make a 3D printed base for this, so it can set right here above the components. You can have feet of different lengths to go down and connect to the boombox. That should give us enough room for everything. And there's actually a Wi-Fi antenna on the Intel Edison. I think we could probably hook that up to the old metal antenna that was on the boombox. All right, I'm gonna scan this into the computer and make a 3D printed base. Then what we can do is we can just leave this as is without having to, you know, pull it out again, make it all one self-contained unit, and then build up from here. All right, Felix has his test board here. Ta-da! All right, I'm gonna plug it into the 5-volt supply. Kapow! Plug the headphones in to our line in that we added. Ready? Here we go. Please don't blow up. All right, so I'm gonna try to start it. I think we need to do a little isolation to clean up the signal. That's on me though. Here's where we're at with the project. We have the base boombox ready to go. We're using the original batteries or the transformer with the AC input. I've attached a line-in jack to the volume, balance, and tone so we can use the original knobs and amplifier for the audio. I 3D printed a plate to bolt the Edison onto. The radio basically does nothing now. I've attached the Wi-Fi antenna to this antenna, ha ha ha. And this switch here will control the power for everything. So yeah, I'm just gonna put the rest of the knobs back in place and then move on from there. Okay, I'm going to replace the buttons on the top of this boombox with some custom-made ones. So yeah, we have switch base, then we'll have the spacer, then we'll have the other spacer, and the buttons go inside of that, and then they click onto the tech switches. We don't have a whole lot of room because the Intel Edison's right here, and we have some ports coming out the top, but I measured it all. It should fit. We had about 0.35 inches to work with. So let's see if it works. We printed this on 3 different printers. The buttons were done on the Robox, the white frame was done on the MakerBot, and the gray frame was done on the FlashForge. I'm now installing the Intel Edison inside of the Boombox. We need to attach the USB audio device, and we have this Arduino shield, which we're going to connect some buttons to, and we can also connect other Grove sensors to it, such as light sensors, sound sensors, gas sensors, dust sensors, and other environmental sensors. Once I get this wired up, we're going to switch this back over to Felix so he can do his Linux magic to get it streaming radio stations from the internet.
So we got the Panasonic Boombox all screwed together, modified, that's pretty cool. And now we need to work on some of the code. I'm just gonna do a button test. Like right now we have these 6 buttons here replacing the pause, fast forward, rewind, play, record, and stop. And this FM stereo LED, we've connected that to the Intel Edison on pin 13. And I'm just gonna do a small button test here. I'm using the Arduino development environment to compile the code, but I'm actually writing the software with a really simple plain text editor, Kate. Here is our button test. We get stop, record, play, previous, next, pause. They're on pins 2, 3, 4, 5, 6, and 7. FM LED is pin 13. All right, we have a timer. We initialize our buttons. We initialize our LED. Anyway, so basically when the button is pressed, it goes low, and if it's low, the FM LED will light. So let's go over here and compile that in our Arduino. All right, that's cool, everything compiled. But now how do we get that onto the Intel Edison without having a serial connection? I'll show you the magic we do here. Since we have SSH going, we can SFTP, which is Secure File Transfer Protocol, into the Intel Edison. I go to the temp directory on my local machine, and this is what just compiled, button test cpp.elf. We've used the Arduino breakout board, and this elf file is what handles all of that. Let's look at it on the terminal. Anyway, so let's SSH into the Intel Edison. That's SSH root at 192.168.1.123. All right, now password. All right, okay, here we go. So right now we're in the root user directory, so let's go to the root directory. That's like where everything is, and we'll go to sketch. Now this is where the sketch.elf file lives. Now we just did this in the terminal, but we can navigate there. This is the file browser named Dolphin that I like to use. We can go to sftp://root at 192.168.123 and then navigate to the sketch directory, and we're in the same place, right? So I want to take this button test.cpp.elf and copy it over here, copy, and it needs to be named sketch. So I can do, just delete this one and then rename it to sketch. Okay, that's good, but now how do we, it's not, the lights aren't coming on, we press the buttons, nothing's happening. So how do we make this happen? There's a file that I had to write, let's look at it, ls/etc/inet.d. In this directory we have 2 files. Automatesketch.sh is the one that I wrote. Let's cat that file, cat and automate sketch. It's a bash file, exec sketch.elf, and then device ttygs0 and ttygs0. Anyway, this is what we have to do in order to get this to work. We just call that file, right? Init.d automate sketch. Now, anytime when the Intel Edison boots up, it'll go in that directory, it'll fire up that file, and then look, now when I press the buttons, the light turns on. Bloop, 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 bloop. Anyway, it's not playing any music, right? So we need to amp up the sketch a little bit to do that. So we took the button test and amped it up quite a bit. We're sending system calls, right? And these system calls, this one will set the output volume. We do system A mixer set headphone 85%, and then we have to redirect the output, because if we don't redirect the output, our sketch will get hung right here and it'll be waiting for this instruction to finish. So we don't really care. We just know that it's going to work. We just spit that out and send the output somewhere else. We're just going to keep going with the program. Oh yeah, we blink the light at 2 different rates. I'll show you that in a moment. And we always gotta, whenever we do play, we always gotta make sure that the audio is set to the right volume, because sometimes the audio changes, but we always want to make sure that the audio is loud enough so that we can hear it. And then also when we change a station, we have to stop the station. We have to stop the media player and then restart it, because I don't believe that MPG123 is an interactive application. So right here in our code, we have MPG, which is the media player 123. All these different system calls will direct us to different radio stations, and the radio stations that we have on here come from Soma FM, which is a online streaming media website. Basically what I did, I went into all the different stations and downloaded their playlists. See the Sonic Universe PLS, and then I opened up the playlists. Let's say here, ClickHop, right? So I went into the playlist that they have for the ClickHop, and I just grabbed their file right here, copied that, and I put it into the system call right there. So it would be like right here. And then again, we need to redirect the output so that when the Arduino sketch calls the media player, it doesn't wait for it to end, it continues with the Arduino sketch. So we redirect the output into oblivion, so we're not waiting for it to do something. As a brief overview of our code here for the Intel Edison Radio Boombox.
All right, Karen, here are all the parts to the Internet Boombox using the Intel Edison.
Tell me more about it, Ben.
Well, we have the Intel Edison, the Arduino breakout board, and then we have our USB audio device here, which is patched into the original amplifier circuit of the Boombox, and you can turn everything on using the tape and radio button.
So what did you actually have to modify of the original radio to make this work?
Well, I had to disconnect the tape circuitry and the FM radio circuitry so we could make it act as just a line into the amplifier side. So this side is all the amplifier. So it's still using the tone, balance, and volume control in the original amplifier IC, and we've isolated out the radio. That way we can use, the things we already have and use as much of the original radio as possible. So yeah, let's put it together. Oh, we can actually even use batteries, so we don't need this plug.
Sweet.
And we were going to add an LCD display to show what channel it was, but there wasn't enough power left on the 5-volt rail. D batteries, they still sell them, I guess. All right, let's try switching it on.
Hit play.
Okay, now you're the dancer, go. Oh man, I'm so tired of this song. Let's do
man, give me some new tunes.
What is this, like the Bingo Lawrence Welk channel?
Kind of elevator / carnival boardwalk music.
Oh wait, it's Christmas music.
Ah! Halloween sound effects channel, apparently.
Christmas Planet? We're gonna see how far we can get from the Wi-Fi router before this thing stops working. Got the antenna.
Oh God, I found Christmas music again! No!
Here.
What'd you do?
Oh, did we lose it?
Oh.
Oh, it's becoming more intermittent. Don't move. Okay, let's go away again.
Pretty good.
Yeah. I stop. Oh, watch out for the ice.
Oh.
The ice made it go away. So we got about 70 feet away from our door out here, and then it's a metal building, and then like another 40 feet to the router in the back of the shop. So that's a pretty good range. Well, that's all the time we have for today.
Can you think of any other pieces of retro tech that you could add an Intel Edison to? Let us know in the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. We're gonna go rock. Can you feel the loaves tonight? No. It'd be funny if Dave Jones did an impression of me. It'd probably be like, I'm an American. I like trucks and bacon. You know, I'm not really into bacon. I mean, it's okay. I'm a rebel. I rebel. I can't believe that line wasn't in the movie. Raise your hands on me. Raise your hands on. Wait, was it raise your hands or no? With special guest star George Lucas.
Your childhood is like poetry, it rhymes. You know, if we can make Jar Jar work, you know, because he's a funnier character than we've had before.
I don't know, I still think Jar Jar kind of gets a bad rap. Well, I think he should be redeemed, I guess is my point. He could be like Forrest Whitaker in Rogue One. He could like be missing like limbs and stuff, and his like ears have been burned off. And then he'd be like, Misa back. Moving to the country, gonna eat a lot of peaches. Moving to the country, gonna eat me a lot of peaches. Peaches come in a can, they were put there by a man in a factory downtown. This holiday season, reach for the nog. High quality eggnog in your grocer's freezer. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.